This lesson explains how to identify linear and exponential models using tables. The graph of a linear function is a straight line. Exponential functions are curves. What does this tell you about the rate of change for a linear function versus an exponential function? Well, linear functions have a constant rate of change. You can tell by looking anywhere on this line and you see that the slope of the line doesn't change at any point. As x increases, y increases, and it's the same amount each time. Over here on the exponential function, at first you have a gradual increase or a gradual rate of change, and then you have a pretty drastic increase or a very steep rate of change. Now remember, linear functions can be written in the form f of x equals mx plus b, and m is that slope or rate of change. The rate of change for an exponential function is not constant throughout the graph. The rate of change either increases, we call that growth, or it decreases, and that's known as decay. Let's take a look at a couple of graphs side by side and see what that looks like. Okay, so here we have two equations side by side, graphed side by side. They're both exponential functions. The graph on the left shows that as x gets bigger, or as x increases, y increases rapidly. Okay? And if we look at it from the other direction, as x gets smaller or decreases, the y values are getting closer and closer to this x-axis, or they're getting closer to 0. Now if we take a look at the graph on the right, we see that as x increases, y decreases pretty quickly. Okay? And if we look at it going in the other direction, as x is getting smaller or decreasing, the y values are getting closer and closer to 0. Now exponential functions can be written in the form f of x equals b to the x power. Notice here that the variable is in the exponent. Now how about we take a look at a couple of tables. Here you want to find the ratio of the y values over the x values between the 4 data points that you have. If it grows by equal differences over equal intervals, then it has a constant rate of change. So let's take a look and see what is the difference between 0 to 10. We're going to add 10 here. To get from 10 to 20, you're adding 10 again, and from 20 to 30, you're still adding 10. So far we have a constant change, but that's just our x values. We've got to consider the y's now. From 375 to 325, we're decreasing by 50 units. From 325 to 275, 325 minus 275 is 50, we're decreasing another 50. And then from 275 to 225, still a decrease, and it's still at a steady 50. From this we can see that as the x values increase by a constant amount of 10, the y values are decreasing by a constant amount of 50. So since the rate of change is constant across the data values, the data set represents a linear model. Now let's take a look at the second table. Look again for a pattern. That'll help you determine what kind of model best describes this set of data. Look at your x values. Let's see what's going on. Negative 2 to 0. Negative 2 to 0, we're adding 2. And 0 to 2, you're adding 2 again. Take a look at your y values. To get from 1/4 to 1, you're increasing the y value by 3/4. And then to get from 1 to 4, you're increasing the y value 3 units. So while the x's are increasing at a constant rate, the y values are not increasing at a constant rate. This data set doesn't have a constant rate of change, and therefore it is not linear. As x increases, y is increasing much quicker. This looks like an exponential function. So you've got no constant rate of change, x is increasing as y increases quickly, exponential. Now you know a bit more about identifying linear and exponential functions using tables. See you next time!